Hi, this is Shyamala Gauri, AP and CSE Department from Rohini College of Engineering and Technology. Subject code CCS 355 Neural Networks and Deep Learning. Unit 1 Introduction. The topics covered in this presentation are Introduction to Artificial Neural Networks and Applications of Neural Networks. Artificial Neural Network. An artificial neural network is a computational model inspired by the way biological neural networks in the human brain work. It is a subset of machine learning, specifically in the field of deep learning, that attempts to simulate the way the human brain processes information. A neural network consists of layers of nodes or neurons, each of which is connected to neurons in adjacent layers. These connections have weights that adjust as the network learns from the data. A neural network typically contains three types of layers. First one, input layer. This layer receives the input features and passes them on to the next layer. Second one, hidden layer. These intermediate layers process the data received from the input layer using activation functions. The deeper the network, the more complex patterns it can learn. Third one, output layer. This layer produces the final result based on the processed data. Next one, the working principle of ANN. First step, forward propagation. Input data is passed through the network from input layer to the output layer using weighted connections. At each neuron, a mathematical function is applied to generate output. Second step, loss function. The network's output is compared to the actual target or ground truth, and the difference is calculated using a loss function. Third step, backpropagation. This error is then propagated backward through the network to adjust the weights of the neurons. This process helps the network learn and minimize the loss. Fourth step, iteration. The above process is repeated for multiple iterations or epochs using a training data set until the model's performance is optimized. Applications of neural networks. Face recognition. Neural networks, especially convolutional neural networks, are used to identify faces in images or videos. This technology is widely used in security systems, social media, and surveillance. Second one, object detection. CNNs are also used for object detection, which helps identify and locate objects in images in real time applications such as autonomous driving and surveillance. Third one, medical imaging. Neural networks are employed for detecting diseases from medical images such as X-rays, MRIs, and CT scans. Examples include detecting tumors, classifying brain disorders, and diagnosing skin cancer. Next one, text classification. Neural networks are used to classify text data into categories such as spam detection in emails or sentiment analysis. Next one, machine translation. Neural networks, particularly recurrent neural networks and transformers, are used in systems like Google Translate to translate text from one language to another. Next one, speech recognition. Neural networks power systems like Apple's Siri, Google's Assistant, and other voice based technologies by converting spoken language into text. Next one, self-driving cars. Neural networks play a key role in the development of autonomous vehicles. They help with image recognition, decision making, and control. Next one, robotics. Neural networks are also applied in robots for tasks such as manipulation, path planning, and interaction with humans or the environment. E-commerce and content recommendation. Online platforms like Amazon, Netflix, and YouTube use neural networks to recommend products, movies, or videos based on a user's previous behavior, preferences, or ratings. These networks use techniques like collaborative filtering to predict what a user might like. Music and video streaming. Neural networks recommend songs or videos based on previous listening or watching habits, helping services like Spotify and YouTube maintain user engagement. Stock market prediction. Neural networks are used for predicting stock prices, identifying trends, and developing automated trading strategies. They can recognize patterns in historical market data that might be indicative of future movements. Fraud detection. Financial institutions use neural networks to detect fraudulent transactions. They analyze patterns of normal and abnormal activity and alert systems when irregular transactions occur. Predictive analytics. Neural networks are employed in predicting the onset of disease based on patient data such as age, lifestyle, and medical history. Drug discovery. Neural networks help in discovering new drugs by predicting how different chemical compounds interact with biological targets, which accelerates the drug development process. Personalized medicine. By analyzing large data sets, neural networks can recommend personalized treatment plans for patients. Weather prediction. Neural networks, especially long short term memory networks, are used to forecast weather patterns by learning from historical weather data. Energy consumption prediction. Neural networks help predict energy demand and supply by analyzing historical data, weather conditions, and other factors. This can optimize energy grids and reduce cost. Game AI. Neural networks are used to create intelligent game agents that can play and compete with human players. Examples include AlphaGo by DeepMind, which learned to play the complex board game Go at a superhuman level. Game design. Neural networks are also being used to generate game environments, characters, and even entire levels automatically. Network security. Neural networks help identify unusual patterns of behavior in network traffic, which can indicate cyber attacks or breaches. Industrial systems. In manufacturing or production environments, neural networks can detect equipment failures or anomalies in production lines, enabling preventive maintenance. Art and music generation. Generative models like generative adversarial networks and variational autoencoders use neural networks to generate new works of art, design, and even music compositions. Content creation. Neural networks are used to generate text such as writing articles, poetry, or stories, and are the foundation behind advanced language models like GPT. Thank you.